Good day, students. In our first class, we talked about safety precautions in the laboratories. Today, we'll be taking our second class that talks about quality assurance control in our laboratories. I know you're going to really be excited for being a part of this very class. It promises to be awesome, it promises to be wonderful. Just come along as I take you through this class and you really enjoy it. I am your facilitator, Dr. Nathaniel Obasi. Thank you. Yes, you are highly welcome. As I told you, as I did in my introductory video. Yes, this is our lesson 2 today, and is actually on quality assurance control in the laboratories. My name, as I said earlier, Dr. Obasi Sunday Nathaniel. By way of introduction, we are going to be looking into the quality assurance controls in the laboratories, and we said in order to achieve uniformity of expression and good understanding, this lesson material adopts the definition of the term quality assurance and quality control as defined by International Standardization Organization (ISO), and also those compiled in FAO 2008. Now, definitions: the quality is defined as the total features and characteristics of a product or service that bears on its ability to satisfy a stated and implied need. Quality assurance means the assembly of all planned and systematic actions necessary to provide adequate confidence that a product, a process, or a service will satisfy given quality. So that is to say that quality assurance is what guarantees quality, what you could have done or put in place that you can beat your chest and say, indeed, I'm pretty sure that this is going to give me quality, that whatever thing I am expecting is what I will get, and not getting something that will not really satisfy the needed expectation in your analytics. Now, the objective of this very lesson is that at the end, that students should be able to understand what quality assurance control means, especially with respect to the laboratory, as well as being able to define quality assurance and quality control in analytical laboratory. Now, the following are very necessary when we talk about quality assurance control in the laboratories, and we say that it has to do with check. You need to be able to check your instruments in the laboratories. You need to check pretty well, check your instruments very carefully to be sure that the instrument is functioning well, is functioning properly. Put all the necessary things in place. Areas that needs to be adjusted, area that needs to be standardized, area that needs to be touched, and all of that. All these things are very, very necessary, and sometimes there might be need for a kind of calibration or standardization of instruments and chemicals. So all of these are very, very important. We will talk about safety, we will talk about quality assurance in our laboratories. Also, adoption of sample check system as a batch control within the laboratories. Each batch needs to be placed in a kind of sample check system. So all of these are very, very important. You need to put your sample checks into action. You need to adopt it so as to be able to ensure that quality assurance is guaranteed. And also, there's what we call external check that has to do with interlaboratory exchange program, wherein some analysis, after it has been carried out in a particular laboratory, you can still send it out to other laboratories for check, wherein results might be compared to be sure that what is gotten here is also what is gotten there. And when that is done, of course, you can be sure that your procedures correct. Now, what are the things that guarantee quality when we talk about quality control in analytical laboratories? It has to do with ensuring that one obtains accurate and acceptable results of analysis on a sample. You need to be very sure that the result you are getting are accurate and they are acceptable. What we mean by being acceptable is any part of the world where you are, any part of the world where this same analysis is carried out, the same result will be gotten. So it is general, and because it passes the same procedure, then the same result should be gotten. Now, the laboratory has to operate in a well-regulated manner, one where the equipment is properly calibrated and the methods and techniques employed are scientifically sound, which will give producible or reproducible result. So what that entails is that this result, the laboratory has to operate in a situation whereby the result you get can be reproducible, can be gotten elsewhere, can be done using the same procedures, and the same result can be gotten. Also, we also have to ensure high standard of quality, which is necessary to follow good laboratory practice. And we'll talk about good laboratory practice. What do we mean by that? What we mean by good laboratory practices means that this can be defined as the organizational process and the condition under which laboratory studies are planned, performed, monitored, recorded, and also reported. Thus, good laboratory practice expects a laboratory to work according to a system of procedure and protocols, while the procedures are also specified as the standard operating procedures. So these are the good laboratory practices are some of the things, the practices that needed to be engaged to ensure that the results we are getting are very, very acceptable. And that has to do with the fact that the procedures are monitored, the procedures are recorded, and can also be reported, and all of that. So we talk about what quality control systems in analytical laboratories really rely on. What are the things that it depends so much on? Quality control system rely heavily on control samples. The sample preparation must be done with great care in order to ensure that the sample is homogeneous. Your sample has to be thoroughly mixed with the reagent and all of that, and the exact number of the exact quantity of a particular reagent that needs to be added should be added across board. So the sample has to be homogeneous if you expect to get a reliable result. And also the sample material has to be stable. It has to be stable. Now the material should have a uniform and correct particle size, as sieve through a standard sieve. For instance, you're analyzing a soil particle, you need to pass the samples through a 2 mm sieve, and when that has been done, of course, all the particles are of equal size. Not when you use 1 mm sieve to sieve a particular sample, you use 2 mm to sieve another sample. Obviously, your results may not be reliable. So all the samples have to be subjected to the same condition, the same sieve, the same temperature, the same everything, and all of that. And when your results, when your analysis are carried out, definitely you should be able to get a reliable result. And also relevant information such as properties of the sample and the concentration of analyte is also expected to be. Now, validation of standard procedures. This refers to the validation of new or existing method and procedures intended for use in many laboratories, which include procedures accepted by the National System of International Standardization Organization. And it also involves an interlaboratory program of testing the method by a number of selected renowned laboratories according to protocols issued to all participants. So when you want to validate a standard procedure, it has to be that some of the samples or the results need to be circulated among several other reputable laboratories, renowned laboratories, wherein it has been known that their results are very good and effective. And when that is done, you should get a good result. So this interlaboratory sample and data exchange program, where an error is suspected in the procedure and the certainty cannot be resolved readily, it is advisable to have the same analyzed in another laboratory or the same system or organization. Also, the result of other laboratories may or may not be biased, hence doubt may persist. So it may be necessary for another accredited laboratory to check the sample in order to resolve the problem. So in conclusion, you have learned that analytical laboratory is considered to be of good quality and acceptable if it has the capacity to deliver the analytical results on a product within the specified limit of error and as per other agreed condition of cost and time